Welcome, everyone. We're going to go ahead and get started. I'm Karen Cook. I'm with the Alameda County General Services Agency in the Sustainability Office, and I will be moderating today's session, which is part of the 2018-19 webinar series hosted by the West Coast Climate and Materials Management Forum. Thank you for joining us to hear from two leaders in materials management from the Oregon Department of Environmental Quality. Before I introduce today's webinar and speakers, I'd like to briefly introduce you to the West Coast Climate and Materials Management Forum. The forum is a collaboration of state and local governments that focuses on developing ways to institutionalize sustainable materials management practices and developing tools to help jurisdictions reduce the greenhouse gas emissions associated with materials. With these efforts, we are trying to answer the question, what are the material sector's opportunities to contribute to the climate solution? Here are some of the tools and resources that the forum offers. They include research summaries and PowerPoint presentations you can use to educate yourself and your colleagues about sustainable materials management. You'll also find a couple of toolkits that can help you incorporate sustainable materials management practices and policies into your climate, sustainability, and solid waste plans. All of these are online at the forum's website, which is on your screen. You'll also be able to find a recording of today's webinar in the resources section of the website. It should be posted on the website within a month of this live recording. So the West Coast Climate Forum series is designed to help environmental management experts share information about existing research, programs, and practices that are reducing greenhouse gas emissions and creating more sustainable patterns of consumption. Today's webinar will consist of one presentation in 3 installments. We'll pause after the first and second installments for a few clarifying questions, and then we'll certainly have more time at the end for moderated questions from you, the audience. You can submit your questions at any time using the question box feature, which can be found in the GoToWebinar dashboard on the right-hand side of your screen. Please note that there may be up to a 10-second delay in slide movement, and also we would love to hear your feedback, and you will have an opportunity to fill out a brief survey immediately following the presentation. And as I mentioned before, you'll be able to find recordings of the presentation as well as the slides at the forum webinar at the forum website, westcoastclimateforum.com. Now, without further ado, let's get on with today's presentations. So here is a description that we sent out about today's webinar. It's pretty long, so I'll paraphrase. The popular attributes such as recyclable and compostable are widely assumed to result in environmental benefits. But how valid are these assumptions? Today we'll hear results of a recently published study that examines the question by reviewing the last 18 years of global research into the environmental impacts of packaging and food service items with and without 4 popular attributes, which are recycled content, recyclable, bio-based, and compostable. Today we have 2 panelists, David Alloway and Peter Canepa. David is a senior policy analyst at the Oregon Department of Environmental Quality's Materials Management Program. At DEQ, David leads projects related to sustainable consumption and production, materials management, including waste management, and greenhouse gases. In 2010, he helped to staff the Materials Management Committee of the Oregon Global Warming Commission's Roadmap to 2020 project. He also led efforts to develop and update Oregon's consumption-based emissions inventory and contributed to ICLEI's U.S. Protocol for Communities and Recycling. Before joining Oregon DEQ in 2000, David worked for 11 years in the solid waste consulting industry. A native of Oregon, David has a BA in physics from Carleton College in Minnesota. Peter joined the Oregon Department of Environmental Quality in January of 2017 to provide life cycle assessment expertise to Oregon's Materials Management Program. Peter's primary role is to conduct and support projects through the application of LCA that advance Oregon towards achieving its 2050 vision. Prior to this role, Peter spent 8 years with ThinkStep, a consultancy specializing in life cycle assessment. Peter holds a master's degree in environmental science and management and a bachelor's degree in environmental studies. And I am your moderator, Karen Cook. So I won't go through my bio in detail, but I'll go ahead and provide a quick introduction to the topic we're covering today before I turn it back over to our presenters who will go in depth on this project. Packaging and single-use food serviceware has loomed large in the mind of the public for many years and is now attracting increased attention from policymakers. Marine plastic pollution is the driving cause of this heightened awareness, and the public is demanding change. But packaging and food serviceware impacts the environment in many different ways, not just marine debris. In the U.S., most of our packaging and food serviceware does not end up in the ocean, but the greenhouse gas emissions from its production both warms the ocean and makes the ocean more acidic. Runoff from agricultural practices used to produce feedstocks are contributing to dead zones in the Gulf of Mexico and elsewhere. Packaging production uses energy and water and can introduce toxic chemicals into the environment. Local governments in the U.S. and elsewhere are responding to the public demand for action by creating mandates based on product attributes. Examples here from the state of Oregon, Seattle, and Santa Cruz require food packaging to be compostable or recyclable. Corporations are hearing the public's demand and are setting their own goals based on attributes of the packaging and food serviceware. IKEA has set a goal to phase out all single-use plastics and replace them with recyclable or compostable products. Danone, Nestle, PepsiCo, and other single-use beverage purveyors are investing in research to produce a 100% bio-based PET bottle to replace the petrochemical PET bottle. And the Ellen MacArthur Foundation has launched a major effort to inspire a circular economy for plastics to address the negative externalities of plastics in the ocean, an effort many corporate entities have signed on to as a way to show their commitment to a better world. Their new plastics pledge requires all plastic packaging to be recyclable or compostable. These are all very well-meaning efforts, but this brings us to the central question of this webinar. Does a given attribute, like recyclable, compostable, bio-based, or recycled, or containing recycled content, always result in environmental benefits? I'll hand it over to David and Peter to tackle that thorny question. I look forward to hearing their input on the important trends that emerge from the research that will inform product design, procurement, and waste management programs. David, over to you.
All right, thanks very much, and good morning or good afternoon, everyone. Let me just get our slides up here. Can you see our slide okay?
Yes, we can.
Great, thanks so much. Okay, so with me is my colleague Peter Canepa, and we're going to sort of popcorn back and forth here. I'm going to start with just a little bit of history and background, and then Peter's going to clarify what we mean by this distinction between attributes and impacts, and he'll introduce the study approach and methodology. We'll take a short pause for questions, and then we'll share with you some of the results of this new research we've just published addressing these 4 attributes. And we'll end with some concluding thoughts and next steps. Again, there will be 2 short pauses for clarifying questions and more time at the end for additional questions. So we'll start here with just a little bit about the project history and background. In 2012, the Oregon Environmental Quality Commission adopted the 2050 Vision for Materials Management. This is a vision shown here, and it also provides a framework for action. That framework is organized into 4 pathways for achieving sustainable materials management: foundational efforts, policies and regulation, collaboration and partnership, and education and information. This vision rests on a foundation of scientific knowledge. We don't want to be promoting an action or an approach if we don't have a clear sense that it's going to move us in the direction of achieving this vision, where we produce and use materials responsibly, conserve resources, protect the environment, and live well. We know that recycling conserves resources and protects the environment. And I would argue it helps us live well as well. Composting also often does the same. But recyclable and recycling are not the same. For example, mercury, elemental mercury, is highly recyclable, but that doesn't make it healthy or safe. Similarly, composting and compostability are not the same. So to know if we're moving in the direction of achieving this vision, we need to ask some fundamental questions. Does it conserve resources? Does it protect the environment? Does it help people live well? These are important questions to ask. This graphic here illustrates a generic life cycle of materials. Each of the stages shown here, such as material extraction, manufacturing, transportation, and disposal, have impacts on the environment. These impacts can oftentimes be quantified, and they include categories such as energy use, freshwater consumption, global warming potential, and the like. It is these impacts we believe that many people want to reduce. We believe that for most people, reducing these impacts are their higher order goals. Reducing these types of impacts are the outcomes that people ultimately want to achieve. But a major challenge is that it can be very difficult to know how different materials actually translate into these types of impacts. So what our society has reverted to instead is a much simpler set of attributes. These attributes, such as compostable or recycled content, are much easier to understand and much simpler to evaluate. And nearly everyone assumes that they serve as reasonable proxies for reducing impacts. That is, if we choose materials that display these attributes, we are going to lower environmental impacts. This assumption is so deeply held and ingrained that many people aren't even aware of the assumption. Governmental and non-governmental programs advocate for or even require the use of these attributes. Businesses widely promote them as well. DEQ has advocated for some of these attributes in the past. Personally, I spent many years encouraging businesses, individuals, and government purchasers to use these attributes. But if our higher order goals are to reduce impacts, we do need to stop for a moment and just confirm that these attributes are in fact reasonable proxies for lower impact materials. That is, we need to confirm that following these attributes will result in reductions in the types of impacts that we care about. So back in 2004, my office commissioned our first ever life cycle assessment. It was looking at e-commerce packaging, and it had one peculiar finding that demonstrated a disconnect between attributes and impacts. We were looking at e-commerce packaging and found that a flexible shipping bag for shipping non-breakable items would result in lower environmental burdens typically than a cardboard box with recycled content void fills, regardless of whether or not the flexible shipping bag was recyclable or not, or contained recycled content. And so it suggested that maybe that popular attribute wasn't always pointing us in the right direction. And then we did a few other LCAs. We weren't looking to ask this question, but we kept stumbling upon examples of where popular attributes weren't aligned with low impact materials. And it got us to wondering, everybody uses these attributes. We assume they're helpful ways of accomplishing environmental benefit. We have these couple of odd examples of how they aren't. Is there any reason to be concerned? Were these examples atypical, or is there something else going on here? Were we unlucky to just happen to find these atypical examples, or might these attributes not be all that they're made out to be? And what we discovered was there's been remarkably little systematic review of these attributes, which inspired this research question. How well do these attributes actually correlate with reductions in life cycle environmental impact? Under what conditions are they helpful for informing environmental strategies? Under what conditions do they result in harmful or unintended outcomes? It's very important to answer this question, as so many organizations are using and even mandating the use of these attributes. So now Peter Canepa here is going to just talk through a bit more about the difference between attributes and impacts and how we evaluate them.
Great, thanks, David. So just as David mentioned, for a little background, so we're kind of all on the level playing ground here for what we mean with these terms. I want to just kind of go through a sort of a thought experiment to compare and contrast attributes and the concept of life cycle environmental impacts. So according to the American Heritage Dictionary, an attribute is a quality or characteristic of a person or thing. And as David already mentioned, you're familiar with these attributes, things like recycled content, recyclability, compostability. There are others which we didn't evaluate: reusability, durability. There are various qualities or characteristics of things, of materials, and that's what we mean by attributes. But these are different from life cycle impacts. So life cycle impacts, on the other hand, require a whole process, which I'm going to walk through, to arrive at. So just let's take a look at attributes and see sort of how we would determine if a material had an attribute. Well, there's not really an official methodology here. This is a little pedantic, but basically one looks at a material and determines whether or not it contains the attribute. And then, as David mentioned, if confirmed, it's often inferred then that that attribute comes with environmental benefits. So let's take an example of a material and an attribute and see if we can go through that process. So if we were to take, say, corrugated cardboard and to arbitrarily pick an attribute bio-based, to go through that process, we'd need to understand the definition of bio-based, which is shown here, materials made from biological or renewable feedstocks that can be replenished. And so then we simply need to ask, does corrugated cardboard contain the attribute or the quality of being bio-based? Since cardboard comes from pulp from wood or trees, we could answer the question, yes, corrugated cardboard is bio-based. So that's the process by which we determine whether a material contains an attribute. Oh, there's the check mark confirming. But can any conclusions about the environmental benefits or costs of corrugated cardboard be made from that conclusion? Is it better than a non-bio-based material? What about bio-based materials made from something other than trees? Can we measure the magnitude of environmental benefits? Those are rhetorical questions. So next, let's kind of go through the same process using life cycle assessment to evaluate environmental impacts. So LCA is based on an international methodology that's been promulgated through a standards making body called ISO, and it comes with an official definition shown here. So LCA, life cycle assessment, is the compilation and evaluation of the inputs, outputs, and their potential environmental impacts for a product or material throughout its life cycle. So already, in contrast to attributes, you can see LCA explicitly addresses and measures environmental outcomes of materials. The process of doing an LCA is actually formally defined. There's a set of steps shown here that one would go through to carry out an LCA, again, based on an international standard. So let's go through the same material example, and instead of using attributes to evaluate it, let's take sort of this life cycle approach. So to do an LCA, remember, we have to evaluate all the inputs and outputs. So we start with, well, how do we make this stuff? We need inputs from both the technosphere and from nature in order to make cardboard. We need wood from trees, water, other inputs from the earth, as well as sort of technical intermediate inputs, electricity, fuels, chemicals. Those all go into a production process. In an LCA, we measure each and every one of those. Of course, coming out of this process, hopefully we get a product like corrugated cardboard, and there may be byproducts or co-products as well. But of course, this process involves other outputs, emissions, which lead to emissions to air, also emissions to water and soil, and the generation of waste that need to be handled further. In LCA, we are accounting then for all of these inputs and outputs. And of course, this must be done across the full life cycle of a product, not just in the step to make it, but to transport that product to market, to use it, and then ultimately to dispose of it. And these inputs and outputs are accounted for across each and every step of the life cycle of a product. So again, to ask some rhetorical questions here, just to clarify, once those inputs and outputs are gathered, then we can translate them into potential environmental impacts like those shown here at the bottom of the slide. So again, to sort of take this rhetorical approach, can any inferences about the environmental benefits or costs be drawn from the LCA process? Can the magnitude be measured? And how would that be different from what we could infer from attributes? So just to conclude and kind of compare and contrast attributes as a decision tool versus impacts, life cycle impacts as a decision tool. The strengths of attributes, as David mentioned, is that they are sort of easy to use and fairly simple, right? They're not too complex to understand. Conversely, life cycle impacts are complex and not easy to arrive at. However, they provide that quantitative, outcome-based, methodologically sound approach to comprehensively evaluate the environmental impact. So there are trade-offs between these two approaches. But if our higher order goals are reducing environmental impacts, I would argue life cycle assessment does a better job at getting us there.
And this is David, just to jump in here. If this assessment shows that the attributes correlate with reduced impacts, that's beautiful. You don't need to quantify these impacts. You can just use the attributes because they are a reasonable proxy for reducing impacts. That's what everyone hopes.
Really great point. Thanks, David. All right, so that kind of sets the frame for the two approaches that we're sort of comparing and contrasting in this research project. So just to set out and answer that research question, we decided, okay, let's use LCA to test whether attributes correlate with reduced environmental impact. So we had a few ways we could go about using life cycle assessment to test this research question. We could have done a bunch of primary modeling ourselves, built a bunch of new life cycle assessment models, collected all those inputs and outputs, and characterized them in terms of environmental impacts. That's a lot of work. I'm the only LCA practitioner on staff. So another option was to go out to published literature. There's been a wealth, LCA is not a new field. There's been a wealth of published, critically reviewed study of different products and materials. So we could just go see what the literature had to say. Or of course, we could have taken some hybrid of the two approaches, where we looked at literature and supplemented with modeling. In the end, we actually landed on doing a systematic literature review. And through some preliminary literature gathering, it kind of became obvious that there was plenty of data, of studies out there to help us answer this question. In fact, so much so that kind of for practical and budgetary reasons, we kind of had to pare down the scope of what we wanted to evaluate. Certainly, we could have looked at these attributes for any product category, the built environment, electronics, textiles and apparel. But again, the constellation of data out there was just too vast for us to tackle it all. And so we ended up paring down the scope of this project, as Karen mentioned, to two product categories, packaging and food serviceware, and also to 4 material attributes, which we've also mentioned, but just to reiterate, they are recycled content, recyclable, bio-based, and compostable. I'm happy at any time to provide definitions for these if that's helpful. All right, so again, we settled on doing a literature review. So in order to gather the literature, we sought out published research in various credible scientific journals, which are shown here. These are sort of the preeminent LCA journal, international journals. And of course, we needed to find published literature that met some specific inclusion criteria that allowed us to answer our question about attributes. So these were the sources, and then the specific criteria that we set to include the literature in our study was that it had to be fairly contemporary, published within the last 18 years, had to be limited to these credible sources, which I just shared. It had to be peer-reviewed and follow the ISO standards for conducting a life cycle assessment. And of course, the study itself must have been comparative. It must have included an analysis of a product, a package or a food serviceware product with the attribute and one without it, because that's ultimately what we were trying to answer. Does the attribute reduce impacts? If so, we needed to compare it to something that didn't have the attribute. This is a bit in the weeds, but just to make this mention, because we were gathering all this literature from different journals and different times, there might be some variance in the setup of each of those studies, right? They might have chosen a slightly different system boundary. One might be older than the other. So to avoid that to avoid the fact that these variances occurred across studies, we didn't actually make any comparisons across studies. I'll come to clarify that in a second, which meant we didn't have to harmonize the data to make it line up across studies. I'll explain how we did that on the next slide. It's a bit of a nuanced point here. Okay, so in order then, once we gathered all this literature that met the inclusion criteria, we needed to come up with a way to evaluate what the literature told us about the attribute and the material without the attribute. So we devised this sort of concept of developing a comparison ratio. That's shown at the top of the table here. And so the comparison ratio is simply taking a impact result published in one of these pieces of literature in which a scenario contained the attribute, say bio-based and corrugated cardboard, and dividing it by a scenario in that same study where the attribute was absent, say steel can, for example. So this is how we devised a sort of a means of evaluating, did the attribute lead to fewer environmental impacts? And we would know that because if the numerator in this equation was less than the denominator, we'd end up with a value that was less than 1 here, right? So we'd have something less than 1. And if it was higher, then that would lead to a ratio greater than 1. And so basically, if you take anything from this slide, all the rest of the results will be shown in green and red. Green generally tends to mean the attribute led to reduced impacts. Red meant it didn't. And finally, just to clarify this, in order to sort of, I guess, scrub out potential noise, we filtered what we deem to be so-called marginally lower or marginally higher comparison ratios, those between 0.75 and 1.25 from our conclusions. They're still shown on the charts, but any conclusions we draw are only from those comparison ratios that resulted in meaningfully lower, that is less than 0.75, or meaningfully higher impacts, that is greater than 1.25. Lastly, I just want to say we didn't do this research alone. We had a lot of help here with an external advisory panel, and their feedback has been pivotal in helping us shape the report and also some summary documents. And I also just want to give a call out to some DEQ staff that aren't presenting to you today. Our colleague Minal Mistry was the project manager, as well as Jonathan Riven was on the project team. And we did hire a consultant, Franklin Associates, to help us perform the literature review. So just a shout out to all of those folks, and thank you. So that gives you a sense of kind of what we're talking about and how we went about answering our question. So now we have an opportunity to take a short pause and Karen, see if there are any questions we should answer now. Thanks.
Great. Thanks for that great introduction. So we do have one clarifying question right now. The audience member would love to see a written list of the definitions for recyclable and compostable, et cetera. Are those available in the report?
Absolutely, they are. I mean, yes, they're in the report. They're taken either from ASTM or U.S. Federal Trade Commission, so we sort of took the preeminent definitions.
And we'll provide a link on the very last slide to the webpage where you can find that report.
Great. Another clarifying question. Please explain how you assign values to the impacts within the example you just gave. There's some more clarification needed there.
Okay, yeah, I'll try to walk through this briefly again. So we gathered a bunch of literature, and the literature was all life cycle assessment studies, which contained a bunch of environmental impact results, right? Quantitative results. You know, a cardboard box correlated with 10 units of greenhouse gas emissions, for example. So those were published in all of this literature, and we just went out to that literature and gathered up all those quantitative results that were published, again, using life cycle assessment. They were arrived at using life cycle assessment. So we just sucked up all that data and then used this ratio shown at the top of the slide to calculate whether the scenario with the attribute was less than or greater than the scenario without the attribute. So we gathered data from a single study and ran it through this sort of comparison ratio calculation and arrived then at these results that you show here, right? So something less than 1 meant that the thing with the attribute was better, something greater than 1 meant that the thing with the attribute was worse, to put it simply. David, you want to clarify?
Just an example. Let's say we found a study that looked at different packaging options for wine, a glass bottle versus an aseptic carton. The glass bottle contains recycled content. The aseptic carton does not contain recycled content. So we said, aha, here is a study that compares 2 options. One has recycled content, one does not. We look and we see that the glass bottle has a carbon footprint of 10. The aseptic carton has a carbon footprint of 20. So the material that has recycled content, that's 10, divided by the material that does not, 20, gives us a ratio of 0.5, and we say, okay, here is one example of where this comparison, the package with recycled content, has a lower ratio, which means it has a lower carbon footprint. We put it in the dark green category.
Yeah, and thanks for walking through that, David. And we did that for every environmental impact category represented, not just carbon, but ecotoxicity, human toxicity, fossil depletion, energy demand, eutrophication, acidification, and so forth. So we did this for each and every quantitative life cycle impact result in the studies.
And there were thousands of those comparisons, which we will now show you if we can go to the next installment.
Okay, why don't we take any additional clarifying questions at the end, or questions around this at the end. So we'll keep those in the queue, and we'll put those back out. So let's move on with the presentation.
Okay, thanks. So let's take a look at some of the results. There's a lot to go through here. We can't show every chart and graph in today's webinar. So I want to note that our website has several resources you might want to check out. For the real serious data junkie, Franklin's technical report is on our site. We've also just added 5 shorter summary documents, one addressing each of the 4 attributes, and then a 5th document that summarizes some associated research involving reusable food service ware. We're also scheduling a series of additional webinars that we'll be hosting in December and January. Participation in each of these webinars will be capped to 30 participants, which will allow for much more discussion. And dates and sign-up information is available on this same project main page. We'll provide you a link at the end of our presentation. Okay, so let's look at the first attribute, which is recycled content. Here's the definition: portion of materials used in a product that have been diverted from the solid waste stream. Looking at packaging, not food service ware, this slide just shows the scope of the studies that were included in the research. We found 20 different studies that met the inclusion criteria, and in those 20 studies, we found a total of 534 comparisons where we could calculate ratios. You can see the types of materials that were included in the study on the left in green, and over on the right in turquoise are the types of environmental impacts which were reported in these studies. We didn't choose these. This is simply what existed in the literature because we weren't doing any original modeling. This is just what other people have studied. So here's the first set of results. I'm going to go through this one fairly slowly so that everyone understands how to read these graphs, and then you're going to see a bunch more of them in the slides to follow. So this slide here is comparing different levels of recycled content for the same packaging material. For example, a glass bottle with 50% recycled content versus 20% recycled content. This graph shows that producing packaging with higher recycled content tends to be environmentally preferable to the same material that has less recycled content. Put another way, if you've decided on using a given material for your packaging, increasing the recycled content of that given material will typically result in lower environmental impacts. How do we know this? The vertical axis here, the y-axis, lists the various impact categories that were included in the literature. The x-axis shows the number of comparisons. Dark green are the number of comparisons that had impact ratios less than 0.75. That is where the packaging with the higher recycled content had meaningfully lower impacts of human toxicity, global warming, whatever, pick your category. Light green are the number of comparisons where there was a reduction, but it was not as meaningful. Dark red are the number of comparisons where there was a significantly greater impact. And pink are the number of comparisons where there was a slightly greater impact. The yellow diamonds are the difference between the dark green and the dark red. It's sort of the net. And the fact that they're all at 0 or in the positive territory, they're all in the green side of the graph, tells us that whether you care about human toxicity or fossil energy or eutrophication or smog, all the literature points in the same direction. Increasing the recycled content of your given packaging material will typically, there are exceptions, but typically result in reduced environmental impacts. Sometimes the reduction is small, sometimes the reduction is significant. Remember, green means the attribute in question results in lower impacts. Green is green. So for the preponderance of comparisons and across nearly all impact categories, increasing recycled content reduces impacts. And let me say one more thing here. We did not evaluate, this study is not a study of recycling. We're not evaluating the benefits of recycling. That question has been answered definitively by many other studies, including a seminal meta-analysis similar to ours conducted by RAP in the UK, which shows that in nearly all cases, recycling a material is preferable to landfilling or burning it for energy. But the connection I want to make is that industry cannot put more recycled content into glass, polyethylene, paper, steel, aluminum, etc., unless those materials have been properly collected and sorted. So it is the act of collection and sorting, which I know many of the people on this call, that's your job. It is that act which enables these environmental benefits as shown on this graph. So again, you've chosen your material, increasing the recycled content of that material is almost always a good thing. Great,
but what if we were comparing different materials? Is recycled content then still a good predictor of reduced environmental impact? So a good example of this question would be comparing, say, a steel container with recycled content versus perhaps a laminate pouch that contains only virgin materials. Both packages are functionally equivalent, right? You can put, say, coffee in both of them, but they have different environmental burdens because they are made of different materials. And of course, one contains recycled content and the other doesn't. So here are the results for recycled content, but comparing different materials as opposed to the one David just showed, which was for the same material. And what you can kind of, I guess, glean from just glancing at this is that the results are somewhat mixed. There's not as clear of a trend as we saw on the previous set of results. And I would argue the results somewhat tend towards the negative side as you move down towards the lower impact categories here. And so, I mean, what does this mean? It means that recycled content alone, when you're, say, choosing between different materials to design your product, is not necessarily a good indicator of reduced environmental impact. In some instances, you might roll the dice and lead to lower impact, and in others, you roll those same dice, you would end up having higher impact. Again, this set of mixed results led us to conclude what I just said, that when comparing different materials, PCR alone is an insufficient predictor of reduced environmental impacts. So to summarize on packaging and recycled content, if you have selected a given material, for example, then increasing the amount of recycled content in that material is usually environmentally preferable. The amount of the environmental benefit that comes with that increased recycled content for the same material really depends on the type of material. And that gets at how materials are made and sort of the processes that go into producing these things. And then thirdly here, if you haven't selected material, if you're just picking from any sort of palette of materials, just selecting for the highest level of recycled content from a mixed palette of materials is not a good predictor of reduced environmental impact. It's a bit of a roll of the dice.
All right, so let's look at the second attribute, which is about recyclable. And again, here we're going to focus on packaging and not food serviceware. So just to be clear, recyclable refers to the potential of a material to be recycled. Recyclability is not the same as the item actually being recycled. And we can all agree that this issue is not as straightforward as simply placing something in your curbside cart and having it hauled away and declaring victory. One of the challenges in evaluating recyclability is that it's not entirely black and white. There's a lot of shades of gray, because recyclability depends in part on, there's geographic variability. There's also differences in how a material might be collected. And we would argue that if a material is accepted in a curbside collection program, it is inherently more recyclable than a material that is technically recyclable, but which you can't put in your curbside bin. Instead, you maybe have to drive it to a retail take-back site. That material is still recyclable, but it is not as easily recyclable. It is not as commonly recyclable. And so the comparisons that we're making in the literature here are actually comparisons of two types. There's comparisons between packages that are like eminently recyclable, like steel cans, versus packages that are really, really not recyclable, like laminate pouches. But then there's also comparisons between materials that are sort of uber recyclable, like cardboard, which can be recycled practically anywhere, and say aseptic cartons, which are not as recyclable. There's not quite as much access to recycling services for those, and sometimes you have to go a little bit out of your way to recycle them. So again, in terms of the comparisons here, we found 18 studies that made a total of 960 paired comparisons. Again, not surprisingly, plastics have been studied the most, but all the materials commonly found in packaging were reflected in this literature. Global warming is the one impact category that everyone evaluates, I think because it's so easy to do, but it's not the only thing that matters to the environment. And there are plenty of other environmental impacts and types of impacts that were represented in the literature. So here's an example again, a glass bottle that is very recyclable versus a laminate pouch that is difficult or impossible to recycle. And what we find is that recyclability in this particular instance is not a good predictor of the environmental burdens. The two containers are functionally equivalent. You could put wine in either of those. Sorry, the bottle is shaped a little bit wrong, but you could. But the inherent environmental profile of these materials is more important, and the amount of materials used ends up being more important than the benefit you get at end of life when the glass bottle is recycled compared to the flexible pouch that isn't. So here's the chart that shows the results. This is kind of similar to what Peter shared with you earlier. There's a lot of green here. In some cases, there's more green than red, fossil energy. Most of the time, the recyclable or more recyclable package, when it's, and this includes the benefits of recycling it, will result in lower fossil energy use, but not always. You can't predict, that with 100% certainty, you're always going to save fossil energy. Water conservation, global warming, again, more often than not, there's more green than red, but we found a fair number of comparisons in the study where the more recyclable packaging had a higher carbon footprint. And then as you work your way down the list here, we start going into red territory where more often than not, the recyclable packaging has higher human toxicity impacts or eutrophication impacts or smog or acidification potential, or interestingly, mineral depletion. And again, this chart reflects the benefits of recycling. It's built into these charts here. So like recycled content, what we find is that this attribute is an attribute that needs to be used with care. Recyclable packaging sometimes is going to be the better choice, and sometimes it's not. And you cannot safely assume when comparing two functionally equivalent packages that just because something is recyclable, that it is inherently the better choice. And again, this is not a critique of recycling. Recycling and recyclability are two different concepts. So the summary here, recycling, the verb, which describes how we can manage our discards when we no longer want them, results in fewer environmental impacts than landfilling or incineration, and more recycling is generally better than less. But recycling and recyclability are different concepts. And when you compare packages that are made of different materials, we find that packaging weight and material type can be a better predictor of environmental impacts than the attribute of recyclability. And the literature is basically inconclusive. regarding whether or not recyclability is beneficial. So that suggests to us that when it comes to packaging design and material selection, recyclability is an important consideration, but it shouldn't be the only consideration. If it's the only criteria you're using in material selection, you're no better off than consulting a Ouija board, essentially. You may or may not achieve the higher order environmental benefits that you're hoping for. And so with that, let's pause for some questions.
Okay, we have a few questions coming in. So if we look at the most recent attribute, recyclability, is it fair to say recyclability often decreases energy use and greenhouse gases, but can increase air and water pollution? Is that how you might frame the results on that?
Well,
or is there a better way to frame it?
Based on this chart here, I think that's pretty close. You know, the thing about this study is that we didn't weight the results based on the market share of the different formats. So this is simply just counting up all the comparisons in whatever's been studied. And I mean, I don't remember if, let's just say, for example, if half of all these data points came from a single study of strawberry packaging, well, then this isn't entirely representative of packaging as it's used today. So one would have to, there's a little bit of caution you would have to have there, but based on an unweighted sampling of all these data points from the, I think it was 20 different studies that compared packaging across a bunch of different formats and industries, that, yeah, more often, I think the way I would say it is, more often than not, recyclability will reduce fossil energy and global warming, but it's not guaranteed to in every case. And more often than not, recyclable packaging will result in higher emissions to air and water in other impact categories. But again, in not every case. So it's not black and white here. It's not like, you know, all people in Texas are Republicans and all people in California are Democrats. It's not that cut and dried.
Okay. Looking back at recycled content, and I think this gets at something you were just saying a little bit. Is there a ranking of which types of materials have less impact on the environment? For instance, using recycled content in cardboard is good, but not great in plastic bottles. Is there anything in the study that points to answering that question?
Well, the way the question was phrased suggests a potential misunderstanding. Using recycled content in anything is good.
Okay.
That's what this graph here shows. Whatever material you're using, increasing the recycled content of that material, according to the studies we reviewed, will often typically result in lower impacts. I think the real question here is, if you're comparing different materials, how do you know which material is better than the other? And is there a general rule of thumb that says paper is better than plastic or glass is better than steel? And Peter, the answer to that question is?
I'm not going to say it, but okay, I'll say it. It depends. And of course, I mean, that is the sort of whole purpose of this project, was to use a method that looks at the full set of inputs and outputs for each given material and then quantify them. So the short answer is we can't, through this study, tell you, yes, paper is always better than plastic. That wasn't the intent of the study. And also that doesn't really reflect the complexity of given materials and product systems. You know, certain materials applied in a given way may look better than they do in another application, right? So the beauty of using life cycle assessment is that we look not only at the material and how it's made and all the inputs and outputs, but the function it's serving. And so the short answer to that question is the study doesn't tell us or rank the materials in terms of their environmental preferability. Though, just as a little bit of an extra thing here, we could do that. We have all this literature. We could go back through and evaluate and rank what did the literature say about a given material in a given application. And we're kind of doing a little back of the envelope for food serviceware to answer that question.
Great. And just one more quick clarifying. how does the assumptions inherent in the LCA, how does it handle end of life for it? Is it including the recycling, whether something is recycled at the end of life? For instance, with your example here, the steel versus laminate bag, how does it incorporate the end of life into that study?
Yeah, so right, for each of the two attributes, we took that into account. So I mean, maybe this is worth digging into a bit, something in LCA methodology which has to do with allocating the benefits or credits of recycling. And there's this question that has to be answered. Do we give the benefit of recycling something to the person who recycled it or to the person or product system that used it? In LCA, there are different approaches or methods to doing that allocation. And one of the methods sort of favors mathematically the use of recycled content, and the other method sort of favors the recycling at end of life. So just one last comment to clarify, we didn't set up these studies, right? So we were sort of beholden to the scope and design of the study by the author of the study. And so, but what we could do is we could filter the results which we showed here. So for recyclability, we filtered these results to only those studies which used the accounting methodology that favored the recycling at end of life, and vice versa for the results we showed you on post-consumer recycled content. We filtered the results only for the studies which used the method that favored the recycled content. These have different names in the LCA parlance, but essentially we tried to filter these results down to give the most favorable result for the use of recycled content and the most favorable result possible for the recycling of materials at end of life.
Right, and that is what we did in these slides here. If you go back to the technical report, you can see the results with and without those filters. Generally speaking, without those filters, the attributes in question here look even worse. There's more red and less green, relatively speaking. But if there's any uncertainty, let me just be absolutely clear here. This recyclable graph is limited to studies that say not only is this packaging recyclable, but it is recycled, and we have accounted for the benefits of recycling it, and we have fully loaded all of those benefits into this graph.
Yeah.
So all the benefits of recycling these recyclable materials are reflected on this graph here.
All right, great. Shall we go ahead and move on, and we will certainly have time for more questions at the end.
Great, thanks, Karen. Okay, so let's dive into our third attribute here, bio-based, and I'm actually going to show some results both for packaging and some food serviceware results here. So just for clarity, this is the definition of bio-based. It's shown here, renewable feedstocks that can be replenished. Typically, these are plant-based, but they could also be the product of the metabolism of a plant, or that could be an animal or an organic waste. So this is what we're talking about when we use the term bio-based. You've seen this type of slide before. This shows the sort of scope of studies and materials that we found in the literature and that we analyzed for bio-based, and this is just for packaging here. So you can see a broad swath of bio-based polymers, so conventional PET, but based on renewable feedstocks, as well as other things like polylactic acid, a common bio-based polymer from corn, and other things, rayon from cellulose and paper and so forth. You can see again on the right in the teal color, a pretty broad swath of environmental impacts evaluated, though again, predominantly global warming and other impacts that often correlate with agricultural production, which is relevant here in the case of bio-based materials. Okay, so here is the first chart. I'm going to show two different charts for bio-based packaging material. And this chart on the left shows the same exact packaging material, but comparing one derived from a bio-based feedstock to one derived from a conventional fossil-based feedstock. For example, biopolyethylene terephthalate versus conventional fossil-based PET. And what you can see is a kind of a pretty clear trend in the first few results. Fossil energy depletion and global warming tend to show that bio-based materials of the same polymer type tend to lead to reduced global warming potential and fossil energy depletion. So green here on the top two lines. But as we move down the chart, we see a sort of a flipping here where other impacts that kind of often correlate with agricultural practices, things like eutrophication, ecotoxicity, acidification, actually look far worse for the bio-based polymers. Now, on the right, if we compare bio-based anything to non-bio-based anything, the results are still mixed, but they've changed a little bit. You'll notice that global warming is maybe less of a clear winner. There's a kind of a mixed bag here in terms of global warming potential. And kind of interestingly, fossil energy depletion is actually higher here than it was when we were looking at the same polymers. So that is to say, bio-based feedstocks are not, of any type, are not necessarily a leading indicator of reduced fossil energy consumption when comparing any kind of bio-based material to any kind of non-bio-based material. So just to sort of draw a bit of a conclusion, the bio-based attribute alone, very similar to recyclability and PCR for different materials, is not necessarily a good indication of reduced environmental impacts. There's a trade-off here, and in particular, a trade-off between sort of global warming impacts and more local water and air impacts. All right, so just quickly to jump to the same attribute, but for food serviceware, here's the summary slide just showing 7 published studies that met our inclusion criteria, allowed us to calculate 327 comparisons for food serviceware. And, you know, this included items such as cups and bowls and plates and utensils. And just to note, one of the biggest sort of concerns we hear about non-bio-based food serviceware is that it's derived from fossil or petroleum-based sources. And 5 of these 7 studies evaluated bio-based food serviceware against non-bio-based food items that were for fossil energy depletion, and that was one of the most commonly studied impacts, as you can see in the teal on the right there, 71%. Okay, so let's look at the results for food serviceware. Again, a sort of a trade-off between global warming and agricultural related impacts. But in the majority of cases here, interestingly, fossil energy depletion lands right on 0, a complete roll of the dice there. But in the majority of cases, there's a lot more red on this chart. Bio-based food serviceware was found to lead to greater environmental impacts, except for in the case of global warming potential at the top there. So not to sort of be a broken record, but you know, there seems to be a trade-off between bio-based feedstocks and non-bio-based, which could be fossil or mineral, so petroleum or metals, and certain impact categories. So we tend to see a reduction in global warming potential at a trade-off for increase to eutrophication potential, acidification potential, and toxicity potential. So just to summarize, then, most comparisons show this trade-off that I just articulated between bio-based and non-bio-based food serviceware. Bio-based materials did tend to have their best performance in terms of reducing greenhouse gas emissions or global warming potential, though those are not consistent across all materials and formats. The trade-offs were driven predominantly by the increase in agricultural production of the feedstocks. And even though there's an increase in agricultural production, we didn't necessarily see a decrease in fossil energy depletion, because a lot of agricultural production, the creation of fertilizers and pesticides and and even running machinery on the field are driven by fossil-based inputs. So they are still relevant even though we're looking at bio-based feedstocks. So let me hand it over to David to talk about the last attribute.
Okay, thanks, Peter. Our last attribute is compostable, the definition shown here. And again, we looked at both compostable packaging and food serviceware. Here's packaging. Most compostable packaging is also bio-based, and so there's some significant overlap between what Peter just presented and what I'm going to show here. We found 10 studies that made a total of 620 comparisons between compostable and non-compostable packaging other than food serviceware. So this would be things like produce clamshells, cushioning, espresso capsules, water bottles, things like that. And here are the results. They are all over the map. They are dominated heavily by one particular study in the literature that focused exclusively on global warming potential. And just to check this, we took the results of that study out of our database. The bars shrink dramatically, but it doesn't change the directionality. There's still more red than there is green. So compostable packaging sometimes results in lower impacts, and sometimes it results in higher impacts. And I mean, sorry, we keep saying the same thing here, but like all these other attributes, it does not offer a reliable proxy for reduced environmental impacts. Again, it's a bit random. It's a bit of a roll of the dice. Maybe you'll get lower impacts and maybe you won't. And for that reason, it's an attribute that should not be used in isolation. If you use it in isolation, you cannot have confidence that you're always doing a good thing for the environment. Finally, compostable food serviceware, 7 studies and 363 comparisons. And this would include items such as plates, bowls, cutlery, cups, things like that. And here, this is one of the few places in the study where we found a fairly consistent and dominant pattern. It all points in one direction, and it's not particularly good. Regardless of whether you care about fossil energy depletion or global warming or smog or ecotoxicity, the compostable food serviceware, even when composted, more often than not in the literature was found to result in higher impacts across the board. Now, there are 3 very important caveats to this data shown here. First has to do with the hypothesized carrier benefit of compostable food serviceware. Compostable food serviceware is often promoted for its benefit at helping to increase the diversion of food waste out of the landfill and into a compost facility. And there will be, in most cases, environmental benefits to doing that. None of the studies, none of the literature, the LCA literature we found, attempted to quantified or even attempted to quantify that benefit. There was one study that simply said, well, if you use compostable food serviceware, then you'll compost food waste. But none of the studies showed sort of the marginal difference, because we know that there are many successful food waste collection programs, for example, throughout most of Oregon, where compostable food serviceware is very rarely used, that capture food waste. You can capture food waste and divert it from the landfill and achieve all the wonderful environmental benefits you do from composting food waste without the use of compostable food serviceware. The question is, how much more food waste do you get when you use compostable food serviceware? And as we think about this carrier benefit, we hear from collectors who say, you know, we're picking up front of the house food waste from Starbucks and McDonald's and KFC. It is all packaging. There is no food. Maybe there's some chicken bones. Maybe there's, you know, half of a Frappuccino. This material doesn't offer a whole lot of nutrient benefit to the compost facility. So the carrier benefit is real. It may not be as large as most people would like to believe it is, and it is not reflected in any of these studies. If it were, there would probably be more green and less red relative to what this chart shows. On the flip side, the second caveat is that none of these studies accounted for contamination at the compost facility of either certified compostable packaging and food serviceware that actually doesn't compost, or the look-alike tag-along materials that inevitably show up when you allow compostable materials into your food waste collection program. And the presence of those contaminants has an impact to the compost facility, and it also has an economic impact, which is not good. And it also has a life cycle impact because the compost facility has to do things like run additional equipment that uses fuels and produces pollution to screen out those contaminants. In some cases, like in some facilities in Oregon, any materials that come into the compost facility, whether they're certified compostable or not, they're going to get screened out at the front end and sent to the landfill because the compost facility just doesn't want to deal with the uncertainty of what's going to happen when you put them into the pile. And so that's just a really expensive way of landfilling these materials, and there are some impacts associated with that extra collection and transportation. And the third caveat is that none of these studies that we've shared with you, none of them address marine debris. They do address other impacts to oceans, such as acidification and global warming. But when compost ends up with all these microplastics in them because you had these lookalike materials that don't break down, that is potentially a vector by which plastics can end up in rivers and lakes and marine environments. And that the impact of that wasn't quantified in any of these studies because LCA simply isn't set up to evaluate marine debris impacts. This last graph here is a bit of a mind bender. It's from a very limited number of comparisons that said, okay, we've got this compostable material, should we compost it? Or should we do something else with it, like send it to a waste energy facility or send it to a landfill where it might sequester carbon, biogenic carbon? And none of the studies suggested that composting the compostable, none of the studies that asked that question found that composting compostable food serviceware was of any benefit whatsoever. It always increased impacts. I want to come back to this chart for a moment and explain why there's so much red and so little green. There's really two reasons for it. The first, and the dominant reason, is because of the feedstocks that are used to make compostable food serviceware. Yes, they may be compostable, and composting food may be a good thing, is a good thing. But the impacts of producing the feedstocks that are used to make the compostable food serviceware, more often than not in the literature, were found to be of higher impact. The second reason that there's so much red on this chart, particularly when you contrast it against the recyclability graph we showed earlier, is that there is very little environmental benefit to actually composting food serviceware. When you compost food, you produce compost, and that compost has environmental benefits. When you compost food serviceware, most of it degrades to carbon dioxide. There's no compost that's produced. There's no environmental benefit to using that compost because there is no compost produced. And the literature generally found that that compostable food serviceware might offer something to the process of composting, but relatively little, and relatively little of environmental benefit. So in summary, most compostable packaging and food serviceware is bio-based and is subject to the same high variability and impacts. Sometimes the feedstocks are low impact, sometimes they are not. If we're never asking that question, we're never going to drive down those impacts. Simply asking for things to be compostable does not send a signal into the marketplace that we value environmental outcomes. Compostable packaging is not consistently preferable to non-compostable packaging. Composting it is generally not preferable. There is this potential carrier benefit. It has never been quantified. And there are sort of countervailing concerns with compost quality and contamination. So that's it on compostability, and we're just going to wrap up our presentation with some reflections on implications and next steps. Peter? Great,
thanks, David. So what do we do with all this information? Certainly there are some high-level implications for various actors who interact with materials like packaging and food serviceware. Designers who are designing purely based on these attributes may inadvertently be increasing environmental impacts, or they may be getting lucky when they're rolling those dice and making a design choice that leads to reduced impact. But the point is, it's an arbitrary roll of the dice when you're basing your design on attributes. So a life cycle approach to design might be more effective at arriving at the environmental outcome you want. And that's sort of the central theme for all these actors. For marketers who are marketing their products based on these attributes, they may be presenting the results in an unsubstantiated way. They may be making claims or inferring environmental benefits using these attributes and creating demand for more of these products with attributes that may or may not lead to reduced environmental impact. So re-envisioning the way a brand thinks about its product and markets the environmental benefits beyond attributes is necessary. Purchasing, a lot of institutional purchasing, even here in the state of Oregon, is guided by these attributes. You must procure things with X, Y, or Z attribute. These might be having unintended outcomes in terms of increasing environmental impact. So again, we need to rethink setting attribute-based purchasing goals. And finally, policies, based on, perceived environmental benefits of attributes can, again, be leading to unintended consequences here. So these are the sort of main actors, but obviously individuals are making choices based on these attributes, and the same conclusion would apply there. So where are we going with this work? Well, as David mentioned, the full technical study is published on our website. The link is coming up shortly. And we've also just completed and published 4 targeted summaries, one for each attribute that tries to sort of distill and simplify this somewhat complex topic. Those are also online. We're sort of promoting and sharing this set of results with folks like you, and hope to have a good chunk of time here to hear your input and critiques and questions. So we're kind of doing a sort of a workshop circuit, both on the web and here in Oregon. And finally, we realized, we cannot make affect change with this study on our own. So we're speaking with groups like the Ellen MacArthur Foundation or the Closed Loop Fund or WWF, who are thinking about these same topics and making sure that they're sort of looking at what these results have to say about attributes. So I guess just a final thought, I would say it seems that we've kind of defaulted to the use of attributes to infer environmental performance. But as these results show, that sort of oversimplifies the reality of making stuff, the complexities of given materials and their life cycle. So I think it's important that we don't distill that complexity down to simple attributional proxies for environmental impacts or benefits. And so in our research, we found only one case where the attribute was generally a good proxy for reduced environmental impact, and that was the first attribute we shared, recycled content of a given packaging material. So I like this picture that Minal, the project manager, took because it sort of summarizes in a simple way the sort of almost silliness here. Now we're putting multiple attributes: compostable, biodegradable, recyclable, please recycle. As a consumer, it's very difficult to make a decision and to understand what any of that means. So I'd just like to end with a quote that is attributed to Einstein: everything should be as simple as it can be, but not simpler. So thank you for listening, and the link to our study is there at the bottom, and we look forward to taking your questions.
Thank you. Well, I don't know about the rest of the audience, but my mind is blown. There is so much information here, and we are getting a number of questions. Let's start with a policy question. You touched on kind of what the results mean for different groups, designers, marketers, policy folks. So, but what would your advice be? What would the answer be on what the government, folks working on policy for large organizations, where should they be focusing if not on attributes? How can we take this and implement it into work?
That's a great question, and I think it speaks to the heart of what we've been trying to do here in Oregon for the last 6 years with our 2050 vision for materials management, and this very intentional transition from thinking about solid waste only to thinking about how do we reduce environmental impacts broadly and holistically across the life cycle of materials. It is, in fact, our society's very narrow and tunnel-like focus on solid waste management that has led to so many of these attributes being so widely accepted, with some unintended consequences, as we've shown here. So broadly speaking, I think it might be helpful to establish and confirm as the foundation of our policy what our higher order goals are, that they are to conserve resources, to reduce pollution, and to help people live well. And that's what we've done with the 2050 vision. With that kind of foundation in place, then I think the next step is to develop a suite of policies that encourage thoughtful evaluation and disclosure of the environmental impacts of different materials. Because clearly what we've shown here is recycling is beneficial. Let me use recycling as an example. Recycling is beneficial, and sometimes the recyclable option will be a better choice, but sometimes it won't. And if we as policymakers, just say everything must be recyclable, period, then we're basically reinforcing a sort of a status quo where people are kind of blindly rolling the dice and hoping for a good outcome. And eventually that outcome will be that we'll have a more recyclable waste stream, and we'll be able to recycle more, and we'll have less to landfill, and we can all declare victory, but it will be a Pyrrhic victory because overall impacts may increase, and that's not what anybody working in this field wants. So what's needed instead is we need producers to start evaluating the environmental impacts of their options and empowered to make decisions that put materials into the marketplace that have lower impacts. I say we need producers to start doing this. What I really should say is we need producers to go back to doing that, because this is what was happening 5 to 10 years ago. And I guess I might share a story to illustrate this point. 10 years ago or so, I got involved with the Sustainable Packaging Coalition when it was first forming, maybe a bit more than 10 years. And one of their very first projects was to develop a simple tool, which was called Compass, which is a rapid screening life cycle assessment tool that allowed packaging designers to do a rapid screening level LCA of different packaging options. I mean, literally, it would take 10 minutes to enter a very minimal amount of data. You would press the button, the software would go boop, 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 and it would spit out this result that told you the relative impact of different choices. And brand owners started using that to make decisions. I walked away from the SPC, not because of anything they were doing, I just got busy with other work. And 2 years ago, I went back to their annual conference, and I was stunned and frankly dismayed to hear senior representatives from Fortune 500 companies, several of them, get up on the stage and say, I'm going to paraphrase, quote, "We used to evaluate our packaging for environmental impacts, but our marketing department tells us that they don't appreciate that complexity, and our customers just want something simple. They just want to be able to recycle everything. So that's what we're going to do. We're going to make everything recyclable, impact be damned," unquote. They didn't actually say impact be damned, but that was certainly what was inferred. They were no longer going to evaluate or select materials based on actual environmental impacts. So what's driving that? Why is the public exerting this pressure? And I would encourage us as policymakers to hold up a mirror and ask ourselves, have we been contributing through our communications and our policy frameworks to that kind of public pressure, which has exerted, frankly, a corrosive effect on industry's willingness and ability to choose low impact materials? Thanks.
Yeah, and I don't want to belabor this point, but I just want to add, we only looked at packaging and food serviceware, and other industry sectors, to David's point, are actively promoting calculating and publishing results on the environmental impacts of their products. It depends on the industry sector and the drivers in that sector. So I think one thing from a policy standpoint we can promote is asking for this information, requiring this information through legislation. And we've seen some of that happen in California, for example, and in the built environment, where California has now said, if you want to sell material for a building, for example, state building, you have to provide a environmental product declaration, which is essentially a life cycle assessment. And and it has to meet a specific baseline or threshold at a given point in time. So that's they're ahead of the curve, but that's a great example of a policy that's incenting business to publish this information. But as David said, having the foundational approach in place first, I think, is the place to start.
I would just go back to the bio-based materials and say, okay, there's all these bio-based materials out there. Some of them are produced with relatively clean production pathways. Some are really dirty production pathways. How can we encourage the clean and discourage the dirty? Simply asking for bio-based isn't going to do it. We need to ask for bio-based. We need to ask for clean bio-based. And so we're simply, at this point in time, not asking the right questions and not sending the right signals to industry about what we want industry to do.
Great. So, and how about if we move from, policy to climate action planning? Is there a step we want to take to include this to focus on the climate side of it?
Well, really, I mean, if you were going to put something about materials in climate action planning, I would encourage you to focus on other materials. Really, I mean, preventing the wasting of food has massive greenhouse gas reduction potential. Ensuring that we have a viable basic recycling system, where core materials get recycled instead of getting dumped, has significant greenhouse gas reduction potential. Peter referenced the built environment, and concrete, that's a material that has a heavy carbon footprint and is easily reduced and could be reduced through municipal action. I just think there are probably better areas if you're going to go after reducing the greenhouse gas impact of materials than packaging or food serviceware.
And kind of following on to that, there's a lot of impact categories that are assessed throughout these studies. And are there tools for folks to use to weigh the different impacts? How do you decide what to focus on because it does range across all of them, or is it really just an average of all?
Yeah, that's a really good question. Yes, there are different methods in life cycle assessment to aggregate or weight and normalize all the impact categories. Those, though, do involve a bit of a value judgment on the part of the practitioner or the commissioning entity for the LCA study, right? What might be important in Eastern Oregon, say water scarcity, may be less relevant here in Western Oregon. So I hate to say it depends again, but there are methods to do this. In fact, there are consensus-based methods where sort of practitioners around the globe have given their expert judgment on weighting and ranking the environmental impact categories. So those are available too if you don't want to make a personal value judgment. I mean, I would argue that climate change is probably one of the more important factors. It's maybe an existential factor that we should be considering, but it is not the only one, right? So I don't have a good answer. It involves some value choice to sort of determine which is the most important factor. I think you could make a fairly defensible argument for focusing your efforts or weighting global warming potential highest.
Okay. Clarifying question on the charts, the results you showed. Are they a compilation of all the comparisons you did, not just the results, for example, of comparing glass bottles with a parallel use container?
Yeah, that's correct. So those charts that we showed, I mean, we gave examples like this might be glass versus steel. Those were examples only. All the charts, every chart represented multiple materials and just whatever comparisons were out there in the literature, and not always the same materials.
Okay, another clarifying question around LCA methodology. So sustainable material management includes impacts during use phase. example, electricity use when operating the appliance during its use life. Life cycle analysis does not, correct? And then follow on to that, are there any LCA standards that do consider impacts during use phase, if that is correct?
The life cycle assessment definitely can evaluate use phase impacts, and many LCAs do where the use phase is relevant. For example, anything that uses energy, anything that's plugged into the wall, cars. I mean, the LCAs on those always focus on use phase because that's where most of the impacts are. Sustainable materials management and LCA both look at the full life cycle when it's relevant. In the case of packaging and food serviceware, they're not quite so relevant. Packaging could be if different types of packaging contribute to different levels of food loss and waste. That could be significant. Food serviceware could be impactful from a human health toxicological perspective due to migration of materials, you know, for example, perfluorinated compounds. But toxicological impacts are what LCA doesn't evaluate. And LCA doesn't evaluate toxicological impacts anywhere in the life cycle. I mean, it does, we could go really deep on this, but just to say, that's really not the realm of LCA to say whether or not a PFAS-treated, how much worse a PFAS-treated paperboard boat is relative to a polystyrene in terms of impact on the user.
Yeah, just to clarify or simplify, yes, LCA absolutely could include the use phase and does when relevant. So if it was published in the literature we sucked up, if that literature included the use phase, that was accounted for. And if it wasn't, because the practitioner following the ISO standards deemed the use phase for their comparative assessment to not be relevant, then it wasn't included.
Yeah, so. Bingo. There was one study, I'm just remembering now, that compared a ready-to-heat ham or some casserole or something in an aluminum tray versus something in like a paperboard carton that the consumer would have to take out of the carton and put in a ceramic dish and put the ceramic dish in their oven, and there were different impacts during the use phase.
Right.
So occasionally the research included use phase, but for these materials, use phase isn't that important for the most part.
Okay, great. Well, we are coming to time. I want to just thank our speakers very much for all this great, challenging work, both for you and for us to absorb. And thank you for your contribution to our understanding on this topic. For the audience on your screen now, you'll see a link again to the Oregon DEQ website where the technical study and the summaries and a bunch of other great information is available. As David said, there will be additional webinars Oregon is hosting, and you can inquire with the DEQ staff or find links to that on their website as well. Anything else you wanted to touch on with that, David? Okay.
Thank you all for staying with us, and we'd love to have more conversation. That's what our future webinars are set up to enable.
Yes, absolutely. I did want to highlight that the West Coast Climate and Materials Management Forum, we're just kicking off our webinar. This is our second webinar in our series for this year. Our next one will be in February, and it's a follow-on to the October webinar that provided an overview of consumption-based emissions inventory. In February, we'll be looking at how to use that information and incorporate it into your programs and make it actionable. So the presentations will be from Urban Sustainability Directors Network, the Carbon Neutral Cities Alliance, and the Cool Climate Network. So do tune in for that. And just to remind you as well that when the webinar ends, you'll get a pop-up window with a short survey. Please do take a minute to share feedback with us. It will help us improve our future webinars. Thank you again to our presenters and to all of you for your time and all the great questions. Please enjoy the rest of your day. The webinar is now over.